Guys, got a after the final project for 6620 and 6999, I got quite a few emails about 3C, and I know you're probably thinking, "Well, I'm done with the class, leave me alone." But there's going to be so many of you that either are or will in your master's thesis going to encounter something like 3C, and I just want to demonstrate briefly how you would take care of that. So, guys, this should be a really quick video. Now, the first thing I want you to keep in mind is I've got the data set here downloaded. I want to do a couple of save as. First thing, I want to call this let's just call it data 1. And data 1 is going to have all of the questions plus gender. But then I also want to delete gender. And I want to do a save as, and I want to call this data 2, because when I run my principal component analysis, it's going to be easier if I don't have to come in and use that data bracket command where I have to go in and take out the first column. So when running just a straightforward principal component analysis, factor analysis, it's just easier if we have just the items up. So I'm going to run accordingly. All right. So gang, what I need to do now is get into R. Don't you hate the spinning wheel? All right. So I'm going to set my working directory. And I'm going to go my data. And I want to, the data I want is data 2, because I want it without gender. And I'm going to attach the data. Now, guys, I'm going to need a couple libraries. The first one I need is Psych. And the other I need is GPA rotation, not rotations, Christy, right? All right, so I've got both of those loaded. Now, the libraries accessed. If you have to do install packages, if after doing the library of Psych and GPA rotation you get an error, then you've got to install the packages. Well, guys, are ready to do something now. I'm not going to beat around the bush. I'm going to go ahead and run the principal. I want to run this on data. In factors is going to be equal to 4. I'm going to assume that we've already explored that. I want rotate to be Varimax. And I want scores equal true. All right. Okay. Yep. As Varimax has to be. Okay. Now, when I look at my principal component analysis, I get what you guys have turned in. About 60% of the variance was explained by these 4 factors. And it appeared to me when I ran this that this is the factor structure that I thought was sufficient. Plus, you can see our probability here is slightly less than 0.05 by about a zillion miles. So we get statistical significance. The 4 components are indeed sufficient. Now, we want to look at our factor scores. And one way to do that is just to pull up our PCA $ scores. And when we do that, notice that we get a factor score for each individual across each of the factors. Now, the primary purpose of problem 3C was to motivate 3D. Well, guys, I had a bonehead moment and forgot to include 3D, which I may talk about in just a second. So, guys, I've got my PCA scores here, okay? But I want to get those into a data frame so I can do something with those. So I would, be real creative here and just call it new data. And I would go data frame, and I would want PCA scores. Okay. Let's attach our new data. And then let's write our new data back to the desktop. So I'm going to go write table, and I want new data to be written to my working directory. Now guys, I have to set this back up here. I have to set my working directory, because wherever this working directory is set, that's where this write table is going to put the file. So I want this file to be the new data that I just saved for the data frame, but I want it to be saved as a .csv file on my desktop. Now when I do that, we can go to the desktop and we can see that we've got a lot of things, data, data 1, data 2, but there should also be this new data file. Now, just so there's no misunderstandings here, I am going to close this file down. I don't need to save it because I've saved it a zillion times. And I'm going to bring up new data.csv. Now guys, this is going to be a trick that a lot of you are going to use when you start analyzing your own stuff. Now, let's make this full screen so you guys can see it. Now the first thing I'm going to do is I'm going to actually come in and I've got my data in text file, or text format. So I need to come up here to data and select text to columns. And I want to use fixed, I want to use delimited. Go next. And I want to separate it by a space. Go next, finish up, and I get my scores sorted. All right, so what I want to do is I want to call this stuff just factor 1, this factor 2, this is factor 3, and this is factor 4. Now, if you have paid much attention throughout, and I need to get rid of all this. This is irrelevant now. If you've paid much attention to the way we've done ANOVA first, a standard one-way ANOVA, we have to have our continuous measures in one column and our independent variable in another. So what I need to do is I need to copy this group of scores, guys. I want to keep in mind where where the last score in the first factor falls. It should be 320 or something like that. And this is extremely slow because I got a lot going on the computer. So it goes down probably to 321. So I want to remember that. So I'll copy those. And what I want to do is I want to paste those right here. This is probably the easiest way to do that. Now I don't need those anymore. Now I want to come in my factor 3s. You'll be able to do this a lot quicker than me because, again, my computer's got... Anytime I have this on-screen capture device going on, it just slows things down pretty significantly. You guys need some Taylor Swift going on, don't we? No, we really don't. All right, so we'll copy those. And we'll scroll all the way down. And let's leave a space there so we know the difference. So let's get rid of that. And then let's go down to the bottom of factor 4. Okay, so copy, come all the way down. Paste it. All right, life is good. Well, I don't know whether life is good or not, but so let's delete that out. Now let's call this scores, and we'll call these factors. So what I want here is this is my first factor, so I'm going to take F1, and I'm going to fill this down. Guys, again, if you're not got a lot going on in your computer, you can do this so quickly, and it's just important to keep things organized when you're doing performing data analysis. I go overboard. There are ways that you can have a lot of stuff going on in R, but when the stakes are high, I tend to play it safe. So, oh, that's not cool. Daggone it. Shoot. There is a way to stop that too. How do we? Is it $sign? Nope. Dadgummit. All right, let's try factor. Just calling out factor 1. Huh. Dad. Shoot. Shoot. Well, let's just call it factor A. I don't guess it really matters. Yeah. All right, that's that kind of. There's a way to handle that. I'm just you could get on and Google it, and essentially doesn't matter what we call it. It matters that we know that these are different factors. Can't help but think my daughters will be like, "Daddy, this is boring." All right, let's do B. I like to, factors you can do is 1, 2, 3, and 4. And once we got in, we could set those up as, do an as is factor, or, but if you use things as letters, it assumes it's a factor. Seriously, we do need some music. Okay. I already had this done earlier. I should have just shown you the result and gone with it, but I like to demonstrate it because a lot gets lost in just the small things, and it's something I've learned with you guys teaching graduate courses. Is it's the little things that seem to throw you all off more than it does the theory or the the more elaborate multi-level test. But it would have been nice not to spend half of my day doing this data set. All right, let's get some I was going to get some music going, but I got to take my finger off of the mouse pad if I do that. Guys, again, most of you are probably fast forwarding anyway, which is cool. Uh, all right, finally, we've got our factors. So, guys, what I would do now is just come back up and get rid of the places that you put in there just to organize. And let's just save this as, I don't know, we're going to perform an ANOVA, so let's be real creative here and call it ANOVA. And CSV. All right, gang, let's go back into R. And I'm going to now, let's call it newest data. And now we're running ANOVA. And I think we called, I don't remember what we called it. Let's look at the names. So we called scores and factors. So let's just run our first model. And when we get this, we can see that our degrees of freedom. Well, I'll tell you what. Let's do this. This is probably better. Okay, so when we run our summary of our model, we can see that our degrees of freedom are 3 and 1276. Some of you missed that. And you can see that your probability is equal to 1. The point I was trying to make on this problem, again, was to set up 3D, which I didn't include, was comparing factor scores across factors is irrelevant because the if we do a t-apply for scores across factors for the mean, what we're going to see is we're going to see that the mean of each one of these is 0. Negative 11, negative 12, negative 11, negative 11 is doing its best to tell you that within certain tolerance of rounding, that the means are equal to 0. This is something I told you back in one of the videos that factor scores within each factor are centered around 0 with a mean of 0. Now, what would have been applicable is to follow up this question with 3D and ask something like, I don't remember what factor A turned out to be. We can go up here and take a look at it if we want. It looks like factor A had question 3 and question 8 and question 10, 11. I think this was the hypothesis testing. So something we could do, which would be kind of cool, is we could actually go into our original data set, which we call data, where we have the gender, okay? And then go to our new data, and let's get this back. Let's highlight. Let me tell you what. Let me get this big enough where you can. All right. So let's go back to data again. Let's get this text to columns. Next space, next and finish. And then let's just get rid of the first. And then we'll call this factor 1, factor 2, factor 3, and factor 4. All right. Now let's copy all this. And let's go back into this where we've got gender. And let's paste. Now, I'm not focusing on my questions anymore, so I want to get rid of those. So I've created a brand new data set here where I have gender across my factors. So I want to come in here with this data set and I want to save it as factor scores. Now I want to go back into R and I want to open up a new data set where I have gender. So I want to come in and call it my, I'm just going to call this data 999. And we can see that data 999 is going to be all the factor scores, but it also has gender. Now the point of 3C is to show you, let me go up here to the top, that comparing factor scores from factor to factor is irrelevant. But comparing factor scores within a factor is not irrelevant. For example, factor 1 dealt with the underlying construct of hypothesis testing. So it would be reasonable to come in and run a t-test over factor 1 over gender. Okay, what have I got going on here? What did I call that? Okay, it's all caps. To see if there's any difference in factor scores across gender. And we can see here that we have a p-value of 0.98, which tells us there's no difference in the factor scores across gender, which is good because you would hope that you wouldn't get into a situation where there would be gender bias, that one gender would perform better than the other across the factor scores. You know, I'm just going to run through this just to show you how easy this now is. I think factor 2 was maybe descriptive statistics. There's no gender difference there. That's good. F3. No gender difference on that one either, but it's more, or at least it's closer to statistical significance. And oh, we actually end up getting gender differences here. Now that's interesting. I don't know what F4. I don't know what. Well, that's interesting. I've got to go check this out. Factor 4 was. It looks like question 4, question 5. So question 4 and question 5. There actually turns out to be a difference across gender in those factor scores. So this underlying construct, whatever those two questions emerged on, I think it was, it may be regression. We can see that there is a difference, which I find to be extremely interesting. So with the value being negative, it means that the first number is smaller than the second. It looks like that the comparison is female, so it looks like that the males performed higher in factor 4. Let's just do that. Let's go F4 gender and do mean. Yeah, so males scored significantly higher on that particular factor score, which is extremely interesting. I'm surprised by that. Okay, so guys, some of you are going to be doing groups, maybe experimental control. So instead of having like female and male, you may have experimental control. Bobby, Jackie, you guys may have, for example, dual credit courses with on-campus courses. So guys, this went far longer than I initially had intended it to, but I just wanted to demonstrate how you actually do 3C and then what I intended for you to do for 3D, but I forgot to include it. So guys, have a good one. Grades have been posted. You guys did great. Great semester. So let's get ready for summer. Take care.